Hey, Algebra 1B. Today we're going to look at problem set 64, which has two topics very closely related. One dealing with something called domain, and the other is additive property of inequalities. Now, this idea of domain, you can see a definition here on the screen, and it's also on the handout. It is, when you see this term domain, it is the set of all possible values for your variable, either in an equation or an inequality. Now, we have solved some inequalities so far, and we have just assumed that our domain is everything. And so if you remember our inequalities, that's the greater than or less than, whenever we solve those and put our answer on a number line, we just shade everything, because we're wanting to say we want all possible numbers, every decimal, every fraction, every weird number, greater than or less than some number. So we have to shade everything on the number line. Well, sometimes we don't want our domain to be everything. So sometimes you might see our domain restricted to be, say, just integers, or maybe just positive numbers or negative numbers, okay? So the two most common domains that you're going to see that we have to deal with in this class are here on the screen. We have domain of real numbers. That's assuming we want everything. All decimals, all fractions, everything. Or we could have a domain where we just have the integers. Now remember, the integers have no decimals, no fractions, so it's just 0, 1, 2, 3, 4, 5, and the negatives, -1, -2, -3. So whenever we put these on the graph, whenever we graph our solutions on the number line, sometimes we're going to shade the number line. That would be for the real numbers. And sometimes for the integers, we're just going to put dots on the integers themselves. Okay? So real numbers, we're going to shade the number line. Integers, or maybe positive integers or negative integers, we're going to put dots. So the way I remember this is integers starts with the letter I. There is a phrase, remember to dot your I's. So the integers, you're going to have dots on the number line. Dot your I's. Okay, so our solutions here, I have two problems here. Just real quick, I'm going to show you how these look on the number line. X is less than or equal to 3. Whenever I put this solution on the number line, when my domain is real numbers, okay, when your domain is real numbers, there's really only one number that we need to see on the number line, and that is the number 3. Now, I put a sample number line on here. I'm not going to go in here and number every single tick mark on there. I'm just going to put a 3 in the middle. Okay, now if you want to put a couple numbers to either side, that's okay. But when the domain is real numbers, you don't need to show me a whole string of numbers. Okay, I just need to know 3. Now, we look at this symbol. What does that little bar underneath that less than sign mean? You should remember that means it can equal. So on our number line, sometimes we put a closed circle, sometimes we put an open circle. You need to remember the difference. The closed circle means we're counting that number. It can equal 3. If it's strictly less than, it has no bar, that means we're going to get right up to 3, but we can't touch it. It can't land on 3. It cannot equal 3. So in that case, we put an open circle. Okay? For this problem, we have less than or equal to 3. So we want to show it can equal 3. So on a number line, we're going to put a closed circle at 3. Now, I need to see and be able to tell clearly that you're showing me an open circle. Don't put a little tiny dot. It doesn't have to be a huge circle, but just make it clear that's a closed circle. Now, I want to shade all the x's. The x's are all the numbers, the solutions, that are less than or equal to 3. So on our number line, the numbers less than 3 are to the left. So I'm going to shade this number line to the left. Okay, and I want everything that direction is our solution. Okay, that's stuff we've already done. Okay, graphing this on a number line, shading one side or the other, open and closed circles. Where it's different is this other problem where we have our domain is integers. Okay, when our domain is integers, I still want the main number, -4. I'm going to put that right in the middle. I'm going to say it's right here. Okay, now I want to see a few numbers to either side. Since these numbers are the little marks are kind of close together, I'm going to go every other one. Make that -2, that's 0, this would be +2, Going this direction, there's -6, -8, -10. Okay, I need a few numbers to either side, and I look at this symbol, strictly greater than, x is greater than -4. Now, it does not have the bar under it, so do I get to put a dot on -4? Well, it can't equal -4, so a lot of times what we would have done in the past is put an open circle. When it's integers, we're not going to put an open circle. So instead, I want to know the first integer greater than -4, and that's the first one that's going to get a dot. Remember, integers, we're going to dot our i's. So the first integer greater than -4 would be -3, which is right here. So at -3, I'm going to put a dot. And I want the rest of the integers, again, no decimals, no fractions, integers greater than -4. So all of these numbers, I'm going to put a dot. And again, make it obvious that you're putting dots on there. Don't just put little tiny little specks. I need to see clearly that there's dots on those numbers. Okay, so when it's integers, I need some numbers on either side of this main number, and then we're going to put dots. Again, dot your i's. So our two main domains that we're going to see, we're going to deal with real numbers, where we shade the number line, and we're going to deal with integers, where we dot. Okay, now this leads us to our next topic, which is additive property of inequalities. Now, we've talked about additive property of equality, which is where we had equations like x plus 3 equals 6, or maybe x minus 7 equals 9. Whenever we solved equations with an equal sign, the first thing we learned on how to solve for x was we're allowed to add or subtract the same number from both sides of the equation. Okay, so on this one we would subtract 3, and we get x equals 3. Over here we added 7. Remember, we do the opposite operation and get 16. Okay? Well, the way this is going to add into our new topic is we're dealing with inequalities where we have greater than or less than. Well, this additive property works when it's an inequality. So we are allowed to still add or subtract the same number from both sides of an inequality. Okay, so we can solve this equation, or inequality rather, solve it for x and get it down to x is greater than or less than some number. And then we can put it on our number line, again noting your domain. Sometimes it's integers, sometimes it's real numbers. Okay, the thing that I suggest, whenever you solve these for x, always try to get the x on the left side of the equal sign. That way it's x is greater than or x is less than some number. That will help it make a little more sense. So these two examples, the x is already on the left. We will get into some more complicated inequalities as we go and talk about multiplication and division properties with inequalities. Okay, but for right now, all you're going to have to do is add or subtract. So looking at this first problem, x minus 3 is greater than or equal to -5. So we solve for x. I'm going to start by adding 3 to both sides. Nothing's changed. This symbol stays greater than or equal to. -5 plus 3 is -2. So here's my solution, and now we're going to be asked to put this on a number line. Whenever you do this, the very first thing you should do is look at your domain and tell, are we going to dot or are we going to shade? This one, our domain is integers. That will be given to you in the problem, so look for that. It's integers, so we are going to dot on the number line. I need the number -2. I'm going to put it kind of here in the middle. Let me switch colors here. Put -2 right here. And this would be -1, 0, 1, 2. We'll go the other way, -3. I'm going to start skipping, -5, -7. Okay? So my solution, x is greater than or equal to -2. This time, do I get to put a dot on -2? You look at this inequality symbol, I see that bar. When that bar is there, that means I get to put a closed circle or a dot on that number. So it can equal -2. So I get a dot at -2, and I want the rest of the integers that are greater than or equal to -2. So greater than -2 is to the right, so we put dots on the rest of these numbers to the right of -2. I'll go ahead and finish this out. You don't have to make your number line this big. Just a few numbers, 3 or 4 numbers to either side of that main number, okay? So again, remember, dot your i's, dots for integers. The second problem here, my domain is real numbers. So real numbers, we're going to be shading on the number line. First thing I need to do is I need to take care of that symbol. When you see a slash through there, that slash means it is not, in this case, greater than. If it is not greater than, then I need to turn that around and make it less than or equal to. So I have this problem. X minus 2 is now less than or equal to -1. I need to finish solving that for x. So my steps for solving for x, I'm going to add 2 to both sides. And we get x is less than or equal to -1 plus 2 is 1. So I have x is less than or equal to 1. Again, my domain is real numbers. So I'm going to shade this solution on the number line. So the main number I need is a 1. I'm going to put 1 right here in the middle. And I need to look, does 1 get an open or a closed circle? Well, I see the bar under there. That means it can equal. So I'm going to put a closed circle at 1. Again, make it obvious that that's a closed circle. And I want less than or equal to 1. So which direction is that? A little hint for you. If your x is on the left side, whatever direction that arrow is pointing, that's the direction you either shade or dot. Since the arrow points to the left, I'm going to shade the number line to the left. All those numbers are less than or equal to +1. Okay? That's the additive property of inequality, where we're allowed to add or subtract the same number to both sides. Again, note your domains. Sometimes they'll be integers and you put dots. Sometimes they will be real numbers and you shade. Open circles, closed circles, all that stuff is still there. We got to remember how to do it. Okay? That is all from lesson 64, domain, additive property of inequality. That's it. Good luck.